Good morning, everyone. How are you feeling? Ready for some awesome DDD stuff today? You're at the right conference. Yeah, so first, I have to excuse myself. I have been speaking at DDD Europe quite a few times, but it's the first time that I'm here in the beautiful red stage. So excuse me a little bit when I'm nervous. I'm Thomas. I'm a principal engineer at Flix. We're doing all these FlixBuses, Flix trains, maybe Flix submarines, Flix roller coasters. We're always looking for new ways of mobility. Yeah, and I'm going to talk about a topic today that some say I'm kind of, well, obsessed about, right? And I talk to a lot of people about aggregates, and I get a lot of questions during conversations, and especially people that are just starting out with DDD are especially interested. So let's get started. I want to give you a little bit of an outlook. The first question is, of course, why do we need aggregates in the first place, right? Why do we need this pattern? I mean, there should be a reason for us to actually use it. The second question is actually, what is an aggregate, right? What is the essence of it? What is this pattern about? And the third question might sound a little bit confusing, but it is actually very relevant. Is how big should an aggregate actually be? What should be inside? What should be outside? Okay, so why do we need aggregates? And of course, I'll start with a quote by Eric Evans from the Blue Book, as every experienced domain-driven designer would do. And it's quite a bit of text, so I'm going to read it for you as well. It is difficult to guarantee the consistency of changes to objects in a model with complex associations. Invariants need to be maintained that apply to closely related groups of objects, not just discrete objects. Yet cautious locking schemes cause multiple users to interfere pointlessly with each other and make a system unusable. So it's quite a bit of text and quite a bit of things to unpack here. So what I want to tell you about is, okay, what kind of situation is he actually talking about? Like, what is the scenarios in which this becomes actually useful? So what I want to show you right now is what complex can actually look like. So anybody has an idea what this is? What is it? No? OK. It's an execution plan for a complex SQL query that involves more than 100 tables, right? And you might think, oh, well, our system will never get there, right? I mean, there's just, I don't know, 4 or 5 entities right now. The problem is when your product or your system becomes successful and you scale up operation, you scale up development, it gets very fast to become there. And it's fun to get there, actually, but it's not fun to be there. So the ride there is very nice. You're in this box, and you get your feature requests, and we're super successful. Oh, a lot of people are using our product, and yeah, features, more features, and yeah, everything is going nice. And at some point, you say, hold on. Why is it taking 3 months to add this small little thing to the system? So we need aggregates that successful systems do not spin out of control, right? Because the complexity is growing with the success of a system. And it's caused by scaling up this operation, scaling up the development, getting all of these new requirements, all these new features, and there's some unbounded growth that we want these successful systems to actually stay successful. That's the reason for the aggregate. We don't only need aggregates. I mean, aggregates are a very small pattern. There's much, much more in the domain-driven design community that we will use, and you are at the very right conference to learn about them. But today I will focus on the pattern of aggregates. So let's dive right in of what an aggregate actually is. An aggregate, again, it's a quote from Eric Evans from the Blue Book. An aggregate is a cluster of associated objects that we treat as a unit for the purpose of data changes. Each aggregate has a root and a boundary. The boundary defines what is inside the aggregate, and the root is a single specific entity contained inside the aggregate. So, let's visualize this. So we start with the boundary, right? So this boundary is a consistency boundary. That means that everything that is within this boundary should be immediately consistent whenever data changes occur, right? Preferably in some kind of atomic operation, maybe an ACID transaction, or other ways of how you can make it consistent. I mean, I'm not saying you should use ACID transactions to do that. There's multiple ways to achieve consistency. But it should be atomic, it should be immediately consistent. So if we have outside and inside, there is something inside, right? And to get from the outside to the inside, you need to have some kind of doorway, right? A door that you can go through to, get some signals from the outside to the inside. So that's where the aggregate root comes in, right? The aggregate root is the doorkeeper that guards, the entry path from the outside to the inside of the aggregate. So all of these data changes are handled through the root. And of course, it's not just the root that does everything. So the root can delegate to things that are inside the boundary. It's a closely related group of objects. It's a closely related group of models. So in this example, we have an account entity as a root, so it would be an account aggregate. And we have like some value objects or some other child entities inside, like a token. And there's also this invariant thing. And people starting out with domain-driven design sometimes get confused what invariants actually are, right? So what does invariant as a word actually mean? It means never changing, even if other circumstances are changing, right? So these are rules that need to be satisfied at all times. And it's also an aggregate's job to enforce these invariants. So we have talked about the outside and the inside. So when the outer world tries to, communicate with an aggregate, it should only have references to the aggregate root. It should only be able to communicate and, pass this aggregate around through the aggregate root. Because the boundary is artificial. The aggregate root is something concrete in your code, right? How you implement the boundary is up to you. It's like you can use a namespace, you can use a module, you can use, an object. It doesn't matter. But you have to, somehow get this invention of the boundary into something concrete that your development team will understand. So if I say the outer world can only have references to the root, exposing references to the insides of the aggregate, on the other hand, should be something to avoid. And the reason for this is not very simple in that case, but I will show you a little bit of examples. And I gave this presentation, in the preparation to my team, and I was asking for feedback, and I had another diagram here, and they were like, Thomas, no, just show some code. And I said, yes. So here we go. It's a little bit of code. It's PHP. Don't blame me. It got a very nice language over the last years. So I'm going to show some examples here right now that are violating these principles. So we get an account from some kind of repository, right? So we have an account aggregate here. So the first violating principle is, giving out a reference to the outer world, right? So you have an account, you get the token, a child entity, and you expose it to the outer world. So you have given out a reference already. And now you do some data changes operations on that child entity that are not guarded by the root. So you're violating the principle that all these data changes should go through the root. Or, for example, an invariant checked outside of the aggregate, right? So there might be a challenge from a request that you create, and you want to confirm the account, and you do this not inside the aggregate, but you do this somewhere in the service layer, right? It's often what we call leaking logic, when logic is leaking from a lower layer to some upper layers. So what are some better approaches here? Again, we get the account aggregate from some repository. And now we invalidate the token through the account aggregate root, right? We're not exposing the token, but we're actually calling the operation. And the implementation of the aggregate is responsible for processing this data change. You're not giving out references anymore. You just return a read-only thing, right? So, OK, I give you the value, but you cannot change it. And now we move the invariance inside of the aggregate, right? So we have the challenge again, but now the account confirms it with this challenge. And if there's something wrong, it will throw some kind of domain exception. So what is an aggregate? It's first a unit of consistency, and it's a unit of concurrency, right? If you remember the quote from Eric Evans in the beginning, it's about keeping it consistent even under a high concurrent pressure. When a system gets successful and you have much more customers, users, whatever, using your product, of course the concurrent pressure will increase. So the next thing I want to show you is a picture of two people. So these are two identical twins. They're called Daniel Tarr and Ben Laszlo Tarr. Who here thinks that Daniel is on the left? 1, 2, 3. Who here thinks that Daniel is on the right? OK. Thank you. Daniel is on the right. I switched the names so to confuse you. But it's impossible to say who is who with the information you have here right now, right? I mean, they wear the same clothes, they have the same hair color, they have the same haircut, they have the same eye color. They probably have the same voice. They're pretty identical. So without them or someone telling you who is who, you won't be able to tell them apart. So in order to compare two aggregates, there needs to be some kind of identity that is attached to that aggregate. And then we would be able to tell two of these aggregates apart. So aggregates are distinct, right? One aggregate with an identity is not the same than the other, even if all the values inside that aggregate would be the same, right? So if you would compare all the values, and they would be the same, but they have a different identity, they're different things. And that's the difference also to value objects, where if the values are the same, they are actually the same thing. And if I say value object and you haven't heard it before, you will probably learn about that later in the conference. So, or you can ask me later about it in the lobby. So again, I want to come back to the quote of Eric Evans. And he especially mentions, for the purpose of data changes, right? So it's about changing things. But for aggregates to be able to process data changes, they have to exist first, right? So this is a timeline, time flowing from left to right. And at some point, there's a genesis of this thing. This thing is created somehow. And this creation is driven by the domain. So it could be that a contract has been signed, or it could be that a customer has registered, or it could be that a car has been produced, right? So there is something in the domain that triggers this kind of birth of an aggregate. And then there is, during its lifetime, it goes through different phases or stages, or it processes a lot of data changes. It does stuff. It does the things it is supposed to do. It is at least useful. I hope it's useful and does useful stuff within your product or your software system. But at some point, there's also an end to it. So it's not just born and then lives forever, but often there is an end. For example, like a contract has expired, or a partner company was liquidated, or a car has been shredded, right? So there is this kind of life cycle that aggregates have. So they represent life cycles. So an aggregate is a distinct life cycle, and it has an identity. Okay, so again, I'm like decomposing this quote by Eric Evans and focusing on small little parts of it, because there's this tiny details. When you read the Blue Book the first time, you thought you understood it, and then you read it a second time and the third time, and then after the third time you understand you haven't understood it at all, and then maybe after the fifth time you start to realize, okay, that's what he meant. So closely related things are normally used together, right? Imagine like your knives and forks and spoons, the cutlery. You probably have them in the same drawer in your kitchen, right? You probably don't put them into like the forks in the living room, the spoons, somewhere in your children's room, under the bed. You put them together. So the same applies to software systems, and the same applies to aggregates. So we have two databases here, database A and database B. I'm specifically not mentioning the technologies. You can just add your own, basically. And on the left side, we have the account entity. On the right side, the token entity. Right? And then you start to, reconstituting this thing from multiple data sources. And, imagine writing this data sources back. So you have to deal with a distributed transaction right now. It gets very, very hard to maintain this consistency. So what this means is that you have put your forks and your spoons into different cupboards, right? Even worse example of this is this one. Who thinks this is a good idea? Who has this running in production? You have now put your forks and spoons onto different planets. You actually need to take a spaceship to get the fork for your dinner. So a much better way is to put these closely related groups that the aggregates represent together, data locality. It's much easier to guarantee the consistency if you store, these things that are inside the aggregate boundary together. It will be much easier to guarantee the consistency. I'm having database shards here as an example, but it could be also microservices, right? I mean, it's about putting the stuff in together. So in this scenario, the cutlery is neatly organized in our drawers. So an aggregate is also a unit of distribution. So let's recap what we have learned so far about aggregates. Aggregates are first and foremost part of the domain and its language, right? They identify some concept there. And if they don't, if you find an aggregate inside your code and you cannot map it to the language that you hear when you speak with your domain experts or your team members, then you should trigger the discussion. Why is this concept here an aggregate, although we're not talking about that at all? We should put it into our ubiquitous language. And I give you a hint, it's always nice to keep a language dictionary in some kind of wiki or something, where you just put all the concepts with the definitions in and invite everyone to add, modify, remove things. There are artificial boundaries around closely related models, like we talked about that, right? The aggregate itself is artificial. The boundary that you put around these closely related models, we have to invent them sometimes. They're nothing concrete. There are life cycles with an identity, right? They're somehow born or go through a genesis, and they end at some point. So nothing on this Earth or in this universe actually is infinite. Everything will end at some point. They're units of consistency, right? They guard the inside from all these messy concurrency, parallel processing problems, that you have on the outside of it, and make sure that it's consistent at all times. They're units of concurrency, as we have just shown, right? It's the existence reason for this pattern. It's about managing this increasing concurrency, managing this increasing load of your successful systems. And they're units of distribution, right? Putting your forks and your spoons together. So what if I need two aggregates? How to keep two units of consistency consistent? Right? We have talked about a single unit of consistency, and it's easy to do that inside the boundary. But what if two of these units of consistency have to interact? And there is some kind of consistency rule between them. So we have this customer registration bounded context, and we have an account there. And whenever this account is opened, our CRM module should also have an account entity. So there's a rule between these two things. And Eric has, again, a quote, that any rule that spans aggregates will not be expected to be up to date at all times. Through event processing, batch processing, or other update mechanisms, other dependencies can be resolved within some specified time. And you probably heard this term very often. What he talks about is eventually consistency, right? The consistency between two aggregates is eventually consistent. And it's clear. You would have to build another consistency boundary around these two things in order to make them immediately consistent. And now add a third one. Now the boundary gets really huge. And at some point, it will be impossible to actually guarantee this consistency. So this brings me to the third question here, which is, it sounds a little bit confusing, but it is actually very much to the essence of domain-driven design. It's about how big should an aggregate be? How do we find out what is inside and outside of this boundary? And to be honest, I can only give you a very unsatisfying answer. It's as big as necessary and as small as possible. I'm not sure who said this quote. It wasn't a conversation, so if you're the person, please talk to me. I will add a proper contribution. So this question of what is inside and what is outside represents the essence of domain-driven design. It's about where do we place the boundaries? How do we decide what is inside and what is outside? And these boundaries are not only in the small tactical world of the aggregate. These boundaries are everywhere. So you will probably learn about context mapping a little bit later, where we talk about boundaries that are on the larger scale and defining the interactions between those things. So we use a lot of methods as domain-driven designers to define exactly that. We use the knowledge of the domain experts, we use heuristics, we use a lot of other techniques that you will learn about today. And you're at the very right conference to understand that at a much deeper level. So thank you very much.
Thank you, Thomas.